Hi everyone, I wanted to make a video to talk about how we can use our concepts from chapter 3 related to quadratics to solve the G-slot. So here's the pre-G-slot question. We have a rectangular picture frame with dimensions of 8 inches wide and 10 inches tall. If the glass on the picture has an area of 48 inches squared, how wide is the width of the picture frame if the frame is the same width all the way around the picture? So let's kind of chat about this. I'm going to move this off the screen so I can write. Alrighty, so let's go ahead. Okay, so there's some things we need to consider here. We have a rectangular picture frame, so we have something that kind of looks like this. Excuse all of my drawings. This is our picture frame. And inside the frame, of course, just like any picture frame that you would hang on your wall or that you would put on your desk, you're going to have glass on the inside of the frame. I know my picture is horrible, but you get the gist. And so, based on the specifications of the problem, it says that the picture frame itself has dimensions of 8 inches wide and 10 inches tall. So I'm clear that my picture is drawn a little funky because if 10 inches is how tall it is, we wanted to go that way. But anyway, process will still be the same, even though my picture is clearly not drawn to scale and clearly I have it going wider than it should than tall. Okay, but this is the point, 8 by 10. And then it says if the glass on the picture has an area of 48 inches, square inches, so the glass would be the black rectangle that I've drawn in here, and its area is 48 inches squared. Okay, that's how much this covers. It says how wide is the width of the picture frame if the frame is the same width all the way around the picture. So what are they asking for? They're asking for the space between the frame and the glass, right? So we want to know this amount of space. That's our question mark. That's our unknown. That's our X. And it says the glass is going to be positioned so that the width is the same all the way around the frame. So basically what they're saying is that it's equidistant on all four corners. So all of these X's, even though my picture, like I said, is wonky, all of these will have the same dimension. So we want to figure that out. Okay. And figuring out one, of course, we'll determine all of them. So I'm going to erase all these. Well, no, I'll leave them. Okay. So we want to figure out this unknown. So we know we have a rectangular shape. So if we want to find and we're given the area of the glass. So let's see how we could find the area of the picture frame itself. All right, so we know that area of a rectangle is length times width, right? Okay. Well, how long is this rectangle? Okay, for our picture frame. So we know that from, I'm going to highlight some pieces. From here to here is 8 inches. And now if we want to try to determine this portion, and I just drew that yellow in, right? We would do 8, and then we'd have to take away this length and this length, because obviously the glass doesn't go from end to end. It can't be as long or as wide as the rectangle frame itself, or else it won't fit inside of it. So we'll do 8 minus the unknown x that is on this side minus the other unknown x that I've circled on the other side. So that's 8 minus 2x. And we'll now multiply it, or try to multiply it. Let's set up how we would find the width. Our width, I'm going to try to use a different color. It's going this way. We have 10 inches. But again, we are trying to talk about this glass thing on the inside. Finding its dimensions. So we'll do 10 minus x minus x. So that's 10 minus 2x. Okay. So now we are able to determine that, hey, this 48 inches squared, that is the area of the glass, can be computed by taking the original dimensions of the frame on the outside, the 8 inches, and subtracting the two corners, subtracting the 2x, and then the 10 inches and subtracting those two corners, subtracting the 2x. So that's how we can use the 48 inches to our advantage to find this area. And now it's simply a matter of solving the quadratics. So we have 48 equals, and we're going to multiply. I'm going to just distribute 8 times 10 is 80. 8 times negative 2x is negative 16x. Now I'm going to distribute the inside. Negative 2x times 10 is negative 20x. And then negative 2x times negative 2x is positive x squared. So we have 48 equals 80 minus 36x plus 4x squared. We want to solve this quadratic, so we want to set it equal to 0, and I'm going to rearrange it because I just like for my equal sign to be on the other side. So we have 4x squared minus 36x plus 80 is 48. I'm going to subtract 48 from both sides of the equal sign so that we're able to set this equal to 0. So then we have 4x squared minus 36x plus, what is that going to be, 32 equals 0. Let me grab my calculator, double check. 80 minus it's 32. Yeah, that was right. All right, so now it equals 0. All right, I'm looking at this. I like easy approaches. I see y'all. I have a 4, a negative 36, a 32, or 0. I know they're all divisible by 4. So I'm going to divide everything by 4. To make my numbers smaller. And then I can go ahead and see if this is factorable, because I prefer factoring. If it is, let's see. So we're left with, divide everything by 4, we're left with x squared minus 9x plus 8 equals 0. Oh yeah, that's factorable. I'm going to, in this video, review some factoring methods that we've discussed so far. So I'm going to do bottoms up factoring. So I'm going to multiply my leading coefficient of 1 times the constant, which is 8. And now I'm going to make the factors of 8, 1, 8. Negative 1, negative 8, 2, 4, negative 2, negative 4. And of these factors, the ones that will add to give me this negative 9, which is my middle coefficient, are negative 1, negative 8. So my factors are x minus 1 times x minus 8, 0. Set each of these equal to 0. So we'll add 1 to this. So x is going to equal 1. Add 8 here. So x equals 8. And now these are the two solutions we got when we solved the quadratic, but now we need to see if they make sense. Okay, so we need to check our answers. So originally we had, I'm going to try to redraw the rectangle kind of situation going on here. What was it? How did I write it the first time? I think I did 8 across, 10 this way. All right. And of course, x is in inches. That's the unit of measure. All right. So now our two answers were that x could equal 1 inch or x could equal 8 inches. We'll see if they both work. So again, this was our x. This was our x. Let's just say we're going this way. This was also x. This is also x, because x are the corner pieces, the distance between the glass and the outside of our frame. All right, so is it possible for this x here to equal 1 inch? In other words, is it possible, right, for us to have a 1 inches here, that's the 1 inches here, 1 inches here, 1 inch, I should say 1 inch, oh gosh, grammar, 1 inch here, and for it to still fit inside of an 8 by 10 rectangle? The answer would be yeah. All right, cool, that works out because that 1 inch fits in the dimensions. But let's say, is it possible for x to be 8 inches? So can I have a frame? Let me erase. This is looking real messy. Can we have a frame? I want to do a new color. Stupid. Okay. Can we have an 8 by 10 inch frame and fit inside of it 8 inches for x, still have a rectangle inside that is 48 inches in area, 8 inches this way? Well, the answer is no, because the two x's alone, if we were to add them by themselves, 8 plus 8 would give us 16 inches that we need to go across or in either direction between the glass frame and the outside of the glass and the outside frame. 16 inches. 16 inches won't fit inside an 8 by 10. 16 inches won't fit in addition to adding that little glass rectangle, it won't fit in there. So x equals 8 does not work. The only answer is x equals 1 inch. So when you're solving these, go ahead and make sure that you remember to check your answers. Now let's talk about what would happen if the question were phrased differently. Let's say the question said we had, let's say we had a room. This is our room. This is a new question, hypothetically. This is our room, okay? In the room, let's say we had